We've been asked to write force equals 4I plus 6J minus 8K newtons in a different way. We've been asked to write it as force equals its magnitude times its unit vector. And then we've been asked to draw the vector in 3 dimensions. So I always like to start with visuals, so let me go ahead and draw that vector in 3 dimensions first off. And so if this is my positive x-axis, and this is my positive y-axis, and up is my positive z-axis because it has to be a right-handed system, and this is my origin, then I can pretty quickly draw this force vector by tracing my path along by going 4, why 4? Because that's what it says right there in the problem statement. I want to go 4 in the I, so 1, 2, 3, 4. Here I am over there at 4I. Remember, I is the unit vector in the x direction. J is the unit vector in the y, and k is the unit vector in the z. So 4 out along the y, and then I need to go a total of 6 out along the j, and so I'm mentally kind of counting off 1, 2, 3, 4, 5. That's about 6. Looks like about 6 to me. And then I want to go minus 8 along the k. Always be sure to kind of pay attention to minus signs. So we're going to go down 8 in the j. So 1, 2, 3, 4, 5, 6, 7, 8. This is approximate. Don't count my numbers. I'll probably be off by 1. Actually, let me try to be more accurate. 2, 3, 4, 5, 6, 7, 8. All right. So to repeat and to kind of make it a little bit bolder, this vector may be visualized as going 4 out along the x, positive 6 out along the y, and negative 8 along the z. So I can draw the vector by going from the origin all the way down to that final point I ended up with, like that. That is my force vector, F. I have illustrated it. I think it helps visualize this to complete the rectangular box, so I'm going to kind of quickly do that. And that helps you, I hope, see in 3 dimensions that this force vector, and I'm going to make it kind of highlight it, is going out along that direction. All right, we've drawn it, so let's do the math now. So first step in writing a unit vector is to calculate the magnitude. Let's give us a better color than yellow. Calculate the magnitude, and so the magnitude of F may be found by taking the square root of the individual components here. So we'd have 4 squared plus 6 squared plus minus 8 squared, which is the same as 8 squared, so I'm not going to write that. And we end up finding that the magnitude of F is equal to 10.77 newtons. So that's our magnitude. Let's put a box around that. Second step is to basically write the unit vector. Unit vector of F is therefore 4 over 10.77 in the I plus 6 over 10.77 in the j minus, don't forget the minus, 8 over 10.77k. And that is the unit vector for F. And so let's put a box around that. The last thing we need to do is basically summarize the answer. And so F, yes, it can be written as 4I plus 6J minus 8K units of Newton. It can also be written as 10.8, and notice that I've rounded it off, newtons times 4 over 10.77I plus 6 over 10.77J. And I've done the calculation on this, and that works out to be 0.371I plus 0.577J minus 0.743K. And so we have these 2 equivalent ways of writing the force vector. And let's put a box around that. The last thing I'd like to comment on is what is this unit vector of F? How would we draw the unit vector of F? How could I draw that? And so I'm gonna zoom in on the diagram. Well, sorry. The way to draw that, and let me try to use a different color still. Let's use, I don't know, gray. So that unit vector can be visualized as being a unit length right here from the origin going in the direction of the corner of that box. And so that is how to draw the unit vector of f. And that's it.